Hey everyone, this is going to be the advanced video of the Behringer 960 sequencer, and we're going to go through some kind of funky, more advanced sort of patching. And yes, in this particular video you're going to need some other modules to get this advanced stuff working. It's not going to be just stuff that you can do within the actual module itself. We're going to be looking at using it with a quantizer or a tuner. We're going to be looking at setting up ratcheting for each step. We're going to look at the audio rate and set up some graphical type waveforms using the sequencer. So I hope you enjoy it, stick around and let's get stuck into it. Just with the lay of the land, we're going to check out the sequencer. This one we're going to do just the quantizer. We're going to be checking out the Expert Sleeper's Disting. This is the Disting Mark IV here. The Disting Mark IV, we're looking at algorithm A6, which is the quantizer. And with the quantizer, what you're going to do for patching is the sequencer itself is currently, I've got this patched through the sequential switch, as you can see here. And the output of the sequential switch is basically your CV pitch per octave, 1 volt, and that goes into the X position on the quantizer. Then the output of the quantizer goes into your oscillator. Now in this particular case, we're going to be using the neutron. The neutron, you know, we could have used modules, we'll use the neutron. One of the reasons why I want to use the neutron is because this actually has a really cool and handy CV matrix here, and we can make use of some of the functions in it, and we'll talk about that later. But just for now, the quantizer, what it's going to do is it's going to help you get the tones into the right frequencies, and I'll show you what I mean. So basically, if we look at just the first step, and we'll launch this thing. So without the quantizer, you can hear it stepping through those steps. In fact, on the disting, you can even see the note being registered. Okay, so it's actually quite handy. So you're getting a visual representation of the note, and you can go through each step on our sequence. So we're going to go E, and then we're going to go and then we'll go to the next one. All right, and let's just say we want just those 3 notes playing on our sequencer, and we don't want this to shift. All right, and we are going to skip it. And that the quantizer is doing our job for us. Okay, pretty easy. Next, what we're going to do is we're going to look at ratcheting. Now, ratcheting is a lot more involved in patching in this. So ratcheting is going to be a couple of different modules. Now, I'm going to put a caveat on this. I think there's probably some better ways of doing it, but this is a real quick and dirty way. You could use the make noise maths to do ratcheting. We'll talk about that in the next section when we talk about the gate length. Anyway, but for now, let's do a basic ratcheting. Now, what we're going to use is we're going to use an LFO, and I've got the LFO over here on the right. It's the 2 HP LFO. And it's just a really basic module, but we're using almost all of the inputs and outputs on this. The only reason why we're not using the second output is because we're only using one of the LFO outputs on it. What's handy about this module is it'll send out a square wave, and in fact, the square wave that's sending out, you guys can actually see it already on the Mordax data here. And the cool thing about that is that I can control the Mordax, the LFO from the 3rd row here on the sequencer. With the third row, anything to the full left is basically going to not increase the frequency range. And as we go to the right, so as we go clockwise on these, we're going to be increasing the frequency range. Now, when you start to see this come in all together, you'll actually understand how this ratcheting is going to work. And it's quite a convoluted patch. So let's go back to the full view and I'll explain how we're patching it. Okay, so the LFO is actually going to be, I mean, it's convoluted because we've got everything going through Mordax so we can actually see what's going on, right? But ignore that. Just pretend that the output of Mordax is actually going into, the LFO is going straight into here. And I'm going to be using an attenuator on the matrix of the neutron. And the reason for it is if I want to turn ratcheting off, I can actually just turn that attenuator down. And you'll see that work in a sec. And then the attenuator out goes into my summing one, and the summing one is the combination of the gate coming out of the sequencer and the second LFO, and that's going into the envelope gate. So let's show how it works. It's pretty basic, but there's a couple of things that we've got to get right first. So what I want to do is I want to go and zoom in onto the Mordax data, and as we're doing the patch, you'll see some of the things going on. All right, so channel 1 is the sequencer clock, all right? And channel 3 is the LFO. Now, if I'm looking at this, I've got to get the LFO clock just about the same time. Doesn't have to be perfect, but it's pretty handy to get it around about the same time as the clock of the sequencer. And when you get the extra control voltage coming in from the sequencer on third row here, that's coming out, that's going into the range or control voltage of the LFO module here, up here. All right, so that's important because as we turn the attenuator up, you'll hear it ratchet. And we can turn it off. So there's your ratcheting. It's pretty convoluted. It's not perfect. I reckon there's a stack of other ways you could do it. You could use an oscillator. I've tried that. You could probably use Batumi. I've tried that. I kind of felt this one was more immediate. One of the things that benefit of this 2HP LFO is it does have a reset gate, and I can actually use any of the channels along here, any of the stages I should say, to reset the LFO clock. And that will kind of, in a way, keep the LFO starting again where we want it to. And that's how we're getting that ratcheting. Right, all right, next one we're going to show is we're going to turn channel 2 on Mordax data. And I'm going to talk about showing how to actually increase the gate length. We're going to turn the visuals of channel 3 off. We don't need the ratcheting shown on this particular video segment. What I want to do is, one of the things that we need to look at, let's just turn off actually channel 2, sorry. Let's just look at the gate. It's a fixed gate on this sequencer and there's no way you can increase or decrease the gate length. But we can, and we can do it using make noise maths. So let's turn it on. And you can see right now the maths is around about the same size. What we're doing is we're coming in on the trigger in, okay, on channel 1. We've got 0 rise. The full is going to determine our gate length. And you can muck around with the logarithmic or exponential knob here. And we're coming out of the EOR output on here. The reason why we're coming out of that is because it gives us a square wave. And we can shorten the gate length and increase the gate length. Pretty cool feature. The next one I want to look at is using the sequential controller in audio rate. And we use that with the oscillator on the left-hand side here. When this oscillator goes into its high range, number 6, and we can play around with the vernier here to adjust audio rate, it's quite a high audio rate. And I'll put a graphic on the screen now to show you what 6 range on that 6 setting there is in terms of hertz. To do this, we're going to need to pull apart some of our patches, but that's okay. We're going to actually get rid of using the sequential switch in this particular case. We don't really need it, so that's not a problem. So the sequential switch will come out of that, and we'll just actually go straight into the first lane. We're only going to use the first lane for this particular sequence. And we can get rid of these two. In fact, we can get rid of the switch, so we can get rid of all of that because we're not needing it. So we're not using 962 for this particular example. But what we are going to be needing to do is we need to actually get the, I want to graphically show you what the audio range, I guess it is, of this second one is going to sound like. Okay, so, and we're not going to use the quantizer. So we're going to go into position 4, and we're going to look at 4 as a graphic, I guess. Now, across here, I want you to look at this as like a piece of graph paper where you've got cells, so from the left to the right, and there's 1, 2, there's 8 cells, right? So the position of the knob is, because you've got 0 to 2 written actually on the actual knob printing, you can see it. So can you imagine if you were to turn this up to 2, that's going to fill 2 squares, one above each other. I'll do a little visual representation on the screen now so you can see what I mean. But we can actually graphically represent this on here by actually, let's take out the sound of sequencer A, because we'll leave that in, and we're going to go, in this particular case, we're going to create an oscillator out of this. And the oscillator, I'm going to have it go through a filter, which is the filter amp module. I'll show you that in a sec. And that's going to come just below here. There's the filter amp module there. And we're going to use this envelope generator to the right here to control our gate from the keyboard, which is just even here. There's the keyboard. Okay. You guys don't need to see that part because that's just, it's like you would just standardly patch it up. But what we're going to do is we're going to show you, we're going to draw this shape first. So I'm going to go full left, and then I'm going to kind of go I'm going to sort of slowly increase this as I go all the way across to the right until the last one. And now we're going to start the sequencer. Now obviously we don't need this firing at the moment, we don't need that. But what we can do is we can have a look at maths showing a visual representation of our oscillator. Increase the frequency. There's our oscillator. And as we adjust, let's go across to here. So now we can see us drawing this oscillator in, and we should be able to zoom in. And you can see each of these steps drawn in. Okay? Now that's the simple part. So this kind of looks like a square wave, and it probably will sound like one. All right, so from the keyboard's CV, we are going to go into the control input of the oscillator here. That's going to give us some control over the keyboard. And then the gate is going to be the gate going into the envelope generator, which we'll do here. That's our gate. And the output of the gate that is going to go into our CV control. Gate is coming out of the keyboard's gate. This is our envelope here. That is firing off our filter and our VCA. This is a VCA filter amp module, and the oscillator, which we've just got patched through, is coming in via that section there. So we should be able to hear this now. There we go, we've got an oscillator happening. All right, let's change the waveform. Let's make a square wave. So we are going to have nothing, 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 and then all the way, all the way, all the way, and then nothing, and then nothing. So this should sound like a square wave. All right, now let's see if we can do a triangle. So the first one, we're going to we want the fourth one to be right in the middle. Kind of a triangle. I'll just show you drawing that. There's our triangle there. Let's do a ramp. It's not a bad ramp. I mean, how cool is that? That is an oscillator. We are drawing graphically our our oscillated sounds. But what we could do is we could use it as an LFO. So why don't we do that? So let's reconnect up our sequence again. We don't want to hear any audio from this, so we're going to disconnect the audio. We don't want envelope generators firing off. Okay, we don't need that. We don't need to control that. So we are good to go with all of that. We can disconnect all the keyboard stuff. Right. But what we do want to do is we want to take the LFO, which we had there, right? This is going to be a ramp LFO, and I'm going to use it to change at an audio rate, and it doesn't have to be an audio rate. We can literally bring it all by the way back down to a non-audio rate, because an LFO is a low frequency. And I'm going to bring that in to my VCF frequency mod, right? Now, we need to bring our envelope gate back in, and you can hear that is already going nuts. And you can actually hear that envelope All right, let's do it to our pulse width modulation. All right, let's adjust this. So as you can see with the second step on the 960, the second step is actually creating that waveform that we can use as a modulation waveform. And you can also do it in audio rate as I showed before. Yeah, okay, this last one I think is kind of interesting. A lot of people don't realize, but there's actually a 9th stage on this sequencer, and that's this one here. And basically what it does is it plays through, and if it sees on the 9th stage a setting here on this, it's either skip or stop, it will do what it's told. Now on that 9th stage, if you set it to stop, it'll just play through the sequence and stop. Now one of the cool features that you could do with this, and it's really, really basic to start and stop things, is you can fire this sequencer off and it can do a bunch of, control voltage modulation on something and stop. And you can use these two inputs here to start it again. So you can have like a gate high and a gate low scenario, and it will fire the sequencer off. And you could have something else like an LFO firing this off. So maybe we could give this a go. Yeah, let's have a play with Batumi on this one, I think. Okay, so on Batumi, we want to have Batumi's square wave coming out, which is the bottom one, right? And we want to have a fairly slow LFO. Now, in this particular case, what I might do is I actually might have a look at this coming out of the 4th channel. So let's chuck that into the 4th channel so we can actually look at our square wave coming out of the Batumi. Probably don't need such a big cable, but there you go. You can see the square wave coming out of Batumi now. Right, and we're going to come out of that and go into, this is going to go into our sequencer on off, and that will start the sequencer. Interesting. So if we lower that speed again, let's just get that time. Okay, so that's kind of not really doing what I want it to do. All right, maybe that needs to go into the stage here. Let's see if that works. Let's watch it now. Yeah, no. So I kind of feel like we need to have like a split of this baby into there. we want to fire off the sequencer and we want to get it to start on that first step at the same time. So, got a little splitter. And good thing about the splitter is that we can actually see what's going on. Let's see if that works. That's cool. So now we've got an LFO that's controlling the starting and stopping of the entire sequence. So if we set this to go faster, like really fast, you'll see this starting to become evident to doing other things. Right, now let's increase our LFO. That is cool. That is so cool. I can't even stop the sequencer now. There we go, it stopped. So that's how that ninth stage works, and it's pretty cool. I mean, yeah, you can have some fun with that. I kind of feel like that's an advanced tip, and that particular tip only required an external clock to a gate to start and stop it. So there you go. Hope you enjoyed the 960 Advanced patching video. Let us know in the comments below what you've been doing with your 960. If there's anything cool, just send us a link to your video or something like that, and I'll go check it out. And if it's actually really cool, I can share it on the Synth Geekery show, which is every Saturday at 1 p.m. In the UK's time, or 9 p.m. in my local city. Do watch that. If you haven't, it's a lot of fun, and we get stuck into a whole bunch of nerdy synth geekery stuff. So a bit like this. Anyway, catch you in the next video.